Now you may ask, what are modules in C? Now, in a typical application, there will be multiple lines, like 10,000, 100,000, to maybe even millions of lines. So it becomes very problematic to have them all in one file. So we split it into modules. As you can see, basically a single application gets split into modules denoted by .h, short for header files. Now these header files will cover one part of the app functionality, and this particular design also helps with usability. So now that we know what are modules, there are three types of module that you will deal with while you are making your application. First is the C standard library, your ftdlib, your math.h. These are used to print things into the output, performing mathematical functions, and multiple other functions. You must have used ftdlib in almost every single program you have made so far as well. So they are part of the C standard library. Second, you can make your own libraries. We will look into it how we can define our own custom made libraries, how we can write our own code, and we can use it across the C files. And third and lastly, there are multiple open source third-party libraries like OpenGL, Vulkan. Some help with graphical processing. Like OpenGL in particular is used for graphic processing, which we will look into an example later on. And there are multiple other libraries as well that you can use to work it out. Now, for the first example, we will use the standard library to perform trigonometric functions. First, we will import the basic library studio.h, math.h. Studio.h will be used for printing the code, printing the output, and math.h will be used to actually determine the trigonometric functions themselves. Then we'll declare the main function. We will use some example. We'll declare some angles. Let's take it a 45 degrees angle, and let's take a radian measure. And to convert radian measure, we'll basically take the angle of degrees times the m pi. This is a standard value for pi value into the in the math.h library. This is defined in math.h, and then we'll divide it by 180 for our conversion into radians. Then we'll basically calculate the trigonometric values using the sine cos tan function inside the mathematics.h library. Then we'll print the results. Now the important thing to note over here is how we will compile. We'll be running the following command. GCC is basically our C code compiler. Using flash o app, we'll be defining our target. This will be the name the app will be saved as. Trick.c is the name we have named our file. And lastly, we will be linking the math.h using the /l m for math module. And we will be running ./app to extend and to essentially run the application in the next command. The output will be something like this. To demonstrate how we can create our own library, I will make a file called mod.c. This will contain two arbitrary functions like this. First, we will define the studio.h library and mod.h, and then we'll define our library functions. This will be, let's make a simple function called greet and a function called square. It just returns squares of the number. Next, in our header file named mod.h, you will simply write if and f mod h to first of all check if mod h have not been defined anywhere else. Once it has not been defined anywhere else, we will simply define it ourselves. Then we will declare the function that we created in mod.c, and lastly we will use the code endf to declare the end of the mod h file. Now in our actual main app, lastly I will make app.c which will store the following code call. First, we will include studio.h and we will include the header file that we have defined before. Then we'll declare the main function. Then we'll basically call the function in the greet. And then we will declare a random number and we will try to get the square of the number using the square function that we have defined in mod.h. To compile this code, we will be using the following command. We'll first be calling the GCC, which is our compiler. Then we'll using ./app to define our target and name. And then we'll be calling both the files app.c and mod.c. And at the end, we'll do a ./app to actually run the file. And its output will look something like this. Now, at the last, I would like to talk about how we can use a third-party library called OpenGL to render computer graphics, something like this. First, we will install the given libraries on our command prompt. I am currently using Windows subsystem for Linux, and I'm using Ubuntu distribution on that. We'll be running this particular command to get our file and libraries installed into the system, and then we will write our. Now in our interactive.c file, we'll first be importing our libraries. This is basically the library required for OpenGL. We'll be defining the math.h library as well to properly define the angles and the other stuff. And we'll basically be using GLM and GLFW to as our OpenGL installations. Then we will define our initial angles. Then this is the code which is actually used to take in the keyboard input and actually process it in the function itself. Then we will create a function called render.cube, which will basically define our initial cube. These are the vertices which I have selected, and currently I'm not really trying to go into the details of the cube, but I'm just really trying to show the initial of how you can set up OpenGL and how we can do the basic of the things. Next, we will be calling our other functions like this is setting up the buffers and the matrix attribute pointers, and basically lastly once the entire cube and everything is deleted, we will be deleting our buffers as well. Then in the main function, we will initialize our glfew windows, and lastly we'll call glfew terminate to terminate the entire app once we close the app. Now once we will command this app, once we will compile this app, the compilation of this code will look like this. Once again, at the end, we are just calling our linker libraries for all of the files in the glfew file systems as well. And once we will compile the code, it will look like this as I showed you in the demo before. As you can see, we can control the demo using our keystrokes as well. And it is working like this. So, in this video, you learned what are modules, what is modular design, why modules are used, and lastly, you saw how third-party modules are used and how you can create your own modules. Now, as you move forward, I would like to give some other suggestions as well. Basically, even in this tutorial, I used a standard called Windows Subsystem for Linux. It is a very interactive system which is used by which is basically allow you to use Linux distros like Ubuntu, Kali Linux, or etc. in your own Windows installation. Now, why I am particularly focusing on Linux is because it is easier to compile this code and check it up on Linux than it is on Windows. In Windows, there is a system, but it is not GCC, and this command will not work if you're trying to use it on a Windows subsystem. So I will suggest that instead of a Windows system, you actually use Windows subsystem for Linux. It is very simple to install. You can go on your Microsoft Store and you can simply download the distribution of your choice, and you can move ahead with this. And with this, I will say thank you for watching.